At Amica Insurance, we know it's more than just a house. It's your home, the place that's filled with memories. The early days of figuring it out, to the later years of still figuring it out. For the place you've put down roots, trust Amica Home Insurance. Amica, empathy is our best policy.
Hey, it's Amy Brown from The Bobby Bones Show. Join me in supporting St. Jude Children's Research Hospital for a chance to win a trip to meet Megan Moroney at the 2025 iHeart Country Festival in Austin, Texas on May 3rd, hosted by Bobby Bones. We're going to hook you up with tickets, flights, hotel, food credits, and a meet and greet with Megan Moroney. Take action now to support St. Jude and help cure childhood cancer, and you're going to be entered for a chance to win. Visit iHeartCountryTrip.com to learn more.
How to have fun anytime, anywhere. Step 1. Go to ChumbaCasino.com.
ChumbaCasino.com. Got it.
Step 2. Collect your welcome bonus.
Come to Papa welcome bonus.
Step 3. Play hundreds of casino-style games for free.
That's a lot of games. All for free?
Step 4. Unleash your excitement.
Woohoo!
Chumba Casino has been delivering thrills for over a decade. So claim your free welcome bonus now and live the Chumba life. Visit ChumbaCasino.com.
No purchase necessary. VGW Group. Void where prohibited by law. 21 plus. Terms and conditions apply.
Hi there. Welcome to The Logic of Risk, episode 12. If you are new to this podcast, I strongly suggest that you listen to our previous episodes, as we are building a discourse on probability and risk step by step. In this episode, we continue discussing logicism before moving on to the axiomatic definition of probability, the last topic in our overview. Let's start. In the previous episode, we talked about Wittgenstein. According to him, probability is a way of distilling a broader logical picture. Every statement perfectly mirrors its part of reality, so when we speak of probability, we are really just focusing on a slice of a larger complete tapestry of propositions. In this view, probability emerges not from a vague property of the word, but from the fact that any single statement only captures a part of the whole picture, much like Laplace's demon illustrates our limited perspective. Then we talked about Keynes and noted that according to him, probability is a logical relation between possibilities or degrees of truth. Given two propositions, there exists only one probability relation between them. I can choose the propositions, but once that choice is made, the relationship between them is determined. It is a unique and objective relation, and any disagreement about it arises solely from a misinterpretation of the initial propositions. According to Keynes, probability should be understood as the expression of the beliefs of a representative rational agent. In this idea of rationality, the economist Keynes truly shines. Like Wittgenstein, Keynes holds the idea that probability arises from a lack of information. If we truly had all the necessary information, then the conclusions we logically arrive at would give us certainties. But given a fixed amount of incomplete information, what we obtain is an objective, logical probability. Speaking of subjectivism, you may recall that I introduced Ramsay. We mentioned that his subjectivism acts as a critique of the Keynesian view. In fact, for Ramsay, who was one of Keynes' students, when Keynes speaks of probability relations between propositions, he never defines them clearly. He merely states that these relations define a universal corpus, detached from individual subjects, and that, in certain cases, they can be clearly perceived. Ramsay, however, rejects these. saying that he personally does not perceive them, and that perception, which is clearly subjective, cannot serve as the foundation for something objective. Thus, Keynes would need a more convincing argument, a need he never quite meets. It must be noted that Keynes' approach is mainly a conditional one. It relates two or more events or propositions. If I know that A necessarily implies B, and if A occurs, then the occurrence of B is certain. If A does not occur, can I then exclude B? And if I observe only B, what can I say about A? This is, in essence, where Keynesian speculation begins. Keynes' assertions regarding the probability of simple propositions, individual facts, that is, just C or just D, without any evident relationships between them, are even weaker and have been subject to criticism. This is because such cases require the use of the principle of indifference, which Keynes seemingly excludes, thereby creating a contradiction. Recall that this principle, as we discussed earlier, requires that in the absence of contrary evidence, every agent must assign the same probability to equally possible alternatives. However, it remains a controversial principle, not easily justifiable in absolute terms. In short, if the Keynesian view seems complicated, it is because it is indeed complicated. Much like Popper's propensity interpretation, which strives to reach conclusions that cannot be achieved objectively while overcomplicating the matter, the Keynesian approach faces similar criticisms. Let's say that neither Keynesian logicism nor Popper's propensity approach fully pass Salmon's test, according to which a definition of probability is adequate only if it meets three criteria: admissibility, ascertainability, and applicability. Admissibility means being compatible with the axioms of probability calculus, that is, with the axiomatic view, which we will discuss in a bit. I would say that all the definitions we have considered are admissible. Ascertainability refers to whether a given definition can yield numerical and measurable probabilities. Here the discussion is more complicated because the propensity approach is not truly capable of handling individual phenomena, much like frequentism. And so, what numbers does it provide in such cases? For logicism, apparently, there are no issues, also because, as in subjectivism, the distinction between mass random phenomena and individual events is much more blurred, if not entirely absent. However, regarding Keynes, there is a nuance. Just give me a minute. Applicability simply refers to the possibility of practically using a given definition of probability. Here we must clarify what we mean by practical. If we refer to specific cases, then I would say that all definitions are applicable, even the classical one. But if we mean a general, uncompromising approach, then it's easy to see almost all the definitions we have considered breaking down one by one, with maybe the exception of the subjective one. And yet, still, I wonder how wise it is to limit ourselves to only a few tools. Now, returning briefly to the ascertainability of the Keynesian view, the answer is it depends. If we mean numerical probabilities, clearly the answer is yes. However, there is in Keynes a truly excellent idea that was for years overlooked, but is now coming back into fashion. And rightly so. The numerical probability, the number between 0 and 1 that we are focusing on, is for Keynes only a specific case of the broader concept of probability, which in itself need not be quantifiable or comparable. In this way, Keynes anticipates ideas such as imprecise probability, according to which it would be more appropriate to reason in terms of probability intervals. Results that often run into the minimal facts we discussed in our early episodes. Along these lines belong also some definitional considerations on indeterminacy, as well as various findings by different scholars on pseudo-probabilities, ambiguity, and more. These are cases that an orthodox approach might not even consider strictly admissible, but these are issues to which we will return in the future. Other scholars of the caliber of Carnap have tried to establish an objective logicist probability, but their results do not differ much from Keynes, unless one restricts probability to very specific branches of logic, neglecting its practical use. In doing so, they leave poor Salmon unsatisfied. More interesting, in my view, is the approach of Jaynes and Jeffreys, which can be seen as a kind of logicism with a more subjectivist twist, as well as a commitment to inductivism. For Jeffreys, in particular, probability expresses a relation between a proposition and a set of data. In other words, probability is a purely epistemological notion that expresses the degree of belief we have in the occurrence of an event based on the given evidence. A reasonable degree of belief is one uniquely determined by the available information. According to Jeffreys, if two people have the exact same information and act logically and rationally, they should arrive at a single identical probability evaluation. If not, one of them is in error, and the other may, if they wish, take advantage of it. This idea echoes Keynes while at the same time standing in opposition to De Finetti, for whom it is entirely natural that two people, even with the same information, may disagree on probability. This is because, according to De Finetti, probability is not rational. Rationality is merely an invention of some scholars and does not exist in reality. In reality, there are our sensations, our more or less founded beliefs, and our limitations. What counts is the coherence of probability with each individual's beliefs, and nothing else. It is on individual events and on the possibility of always expressing numerical probabilities that Jeffreys aligns with De Finetti, distancing himself from Keynes and even from the frequentists. For Jeffreys, it is always possible to define a probability and elicit it, something that neither Keynes nor von Mises nor, if you recall, Peirce consider feasible. Jeffreys, like Jaynes, was also a fervent Bayesian, advocating the use of Bayes' theorem as a method of learning in statistics and dealing with uncertainty. Indeed, if probability depends on the available information, it is natural, according to Jeffreys, that when this information changes, the subject updates the probability. However, his logicist tendencies led him to define the so-called Jeffreys priors, which tend to be less subjective, not as closely tied to the evaluator's personal beliefs, but more connected to empirical evidence. This is exactly in line with his view of probability as a relation between a proposition, an event, and a set of data. In short, you can see that the logicist view of probability is quite rich because of its hybrid nature. Jaynes, for example, similar in many respects to Jeffreys, tends to be more subjectivist than the latter, aligning more with De Finetti while still maintaining a logical approach. The interesting thing about Jaynes, simply put, is his idea that probability is not the product of our knowledge and our beliefs, but rather the apophatic result of our ignorance. Probability derives from what we do not know.
Hey, it's Amy Brown from The Bobby Bones Show. Join me in supporting St. Jude Children's Research Hospital for a chance to win a trip to meet Megan Moroney at the 2025 iHeart Country Festival in Austin, Texas on May 3rd, hosted by Bobby Bones. We're going to hook you up with tickets, flights, hotel, food credits, and a meet and greet with Megan Moroney. Take action now to support St. Jude and help cure childhood cancer, and you're going to be entered for a chance to win. Visit iHeartCountryTrip.com to learn more.
Looking for excitement? Chumba Casino is here. Play anytime, play anywhere. Play on the train, play at the store, play at home, play when you're bored. Play today for your chance to win and get daily bonuses when you log in. So what are you waiting for? Don't delay. Chumba Casino is free to play.
Experience social gameplay like never before. Go to Chumba Casino right now to play hundreds of games, including online slots, bingo, Slingo, and more. Live the Chumba life at ChumbaCasino.com.
No purchase necessary. VGW Group. Void where prohibited by law. 21 plus. Terms and conditions apply.
Once again, Laplace demon makes an appearance. Jaynes formalizes this idea of probability as ignorance very effectively using the physical concept of entropy. But let's close these logicist parentheses here. I plan to add further details when the opportunity arises. As I mentioned last time, today, given the resurgence of machine learning, many logicist insights have interesting applications. The last definition I want to briefly consider with you, merely as an introduction, since it will accompany us in the rest of our conversations and we will have the chance to delve into it, is the axiomatic definition. In reality, the axiomatic definition is a known definition. It defines what probability is, but in a purely mathematical way, without concerning itself with everything we have said about subjectivity and objectivity. According to the axiomatic definition, probability is something metaphysical that obeys certain mathematical properties which are assumed as axioms. This definition, traced mainly to Kolmogorov, though it already found a strong supporter in Hilbert, stands above the fray. It does not get its hands dirty with objects, subjects, propositions, propensities, and all that mess. No, in a grand spirit of mutual respect, the axiomatic definition agrees with all the other definitions as long as they don't cause trouble and satisfy its basic axioms. This is why Salmon requires that the various definitions be admissible. They must be compatible with the axiomatic one. And why? Because the axiomatic definition is the basis of probability calculus, the starting point for all models and formalizations. There are alternative metaphysical approaches, but at the moment they are in the minority. So, what are the properties required of probability to define the axiomatic view? There are three, from which we can derive, according to mathematical criteria, fundamental theorems and methods for probability calculus. Axiom 1. Non-negativity. The probability of an event in the sample space is a non-negative real number, that is, it's greater than or equal to 0. Remember, the sample space or state space is nothing other than the set of all possible outcomes of a random phenomenon. Axiom 2. Normalization. The probability of the certain event, defined as the occurrence of at least one of the simple events that make up the sample space, is equal to 1. For example, in our case of a die roll, if I roll the die, something will happen with probability 1. This is known as the normalization axiom, and it allows us to distinguish probability from other quantities used in measure theory, a very important branch of mathematics. Axiom 3. Sigma additivity. If we take a sequence of mutually exclusive events, the probability of the union of all these events is equal to the sum of the probabilities of the individual events. Recall that two events are said to be mutually exclusive if the occurrence of one cannot happen simultaneously with the other. This third axiom is the most subtle of the three, and its discussion could easily be the subject of 2 or 3 university lectures, depending on how meticulous or pedantic the professor is. Here we will simply say that in taking the sequence of events, these can be infinite in number, provided they are countable. That is, in a hypothetically crazy attempt to count them, we can do so using the natural numbers 0, 1, 2, 3, 4, which, as you know, are infinite. In mathematics, there exist different types of infinity, and countable infinity is the easiest to grasp. I won't go any further, lest we fall into a black hole from which we might never escape, and perhaps go as crazy as poor Cantor. Thus, the third axiom, also known as sigma additivity, tells us that we can sum probabilities indefinitely, and that the sum of these probabilities will equal the probability of the union of all the considered events, provided they are mutually exclusive. If they are not, one must account for the intersections so as not to count the same sub-event more than once. From these axioms, we can immediately derive fundamental results. For example, that probability is a number between 0 and 1, that the probability of the null or impossible event is 0, or that if the probability of a given event is p, with p a number between 0 and 1, then the probability of its complement is 1 minus p, and so on. A small side note. Even on Kolmogorov's axiomatic view, De Finetti, and not only him, had objections. In fact, for De Finetti, just as the concept of the frequency limit, which requires waiting an infinite amount of time, is meaningless, so is summing probabilities ad infinitum. For De Finetti, probability must deal with the finite, since we humans are incapable of handling infinity. After all, if probability is subjective, it also depends on our limitations, such as our inability to count to infinity. Thus, for De Finetti, the third axiom should be replaced with one of simple additivity, where the sum over events is finite. The events can be many, but not infinite. Philosophically, I share this view. As mentioned, we will return to the axiomatic view several times in future episodes, since it represents the framework within which we will define many objects of interest, such as risk measures. It is only when we put different models and tools into practical use that we cannot avoid getting our hands dirty, descending from Kolmogorov's realm of ideal forms and returning to the debates between objectivists and subjectivists. Alright, that's enough for today. I believe I should stop now, also because we are exceeding the 20-minute limit, but we do it for a good cause, as they say. I would like to close with a quote by Bertrand Russell. Quote, "Probability is the most important concept in modern science, especially because no one has the slightest idea of what it means." Unquote. Until next time, if you are willing to take the risk. And yes, we will be back to risk indeed. Ciao ciao!
At Amica Insurance, we know it's more than just a house. It's your home, the place that's filled with memories. The early days of figuring it out, to the later years of still figuring it out. For the place you've put down roots, trust Amica Home Insurance. Amica, empathy is our best policy.
Hey, it's Amy Brown from The Bobby Bones Show. Join me in supporting St. Jude Children's Research Hospital for a chance to win a trip to meet Megan Maroney at the 2025 iHeart Country Festival in Austin, Texas on May 3rd, hosted by Bobby Bones. We're going to hook you up with tickets, flights, hotel, food credits, and a meet and greet with Megan Maroney. Take action now to support St. Jude and help cure childhood cancer, and you're going to be entered for a chance to win. Visit iHeartCountryTrip.com to learn more.
Looking for excitement? Chumba Casino is here. Play anytime, play anywhere. Play on the train, play at the store, play at home, play when you're bored. Play today for your chance to win and get daily bonuses when you log in. So what are you waiting for? Don't delay. Chumba Casino is free to play.
Experience social gameplay like never before. Go to Chumba Casino right now to play hundreds of games, including online slots, bingo, Slingo, and more. Live the Chumba life at ChumbaCasino.com.
No purchase necessary. VGW Group. Void where prohibited by law. 21 plus. Terms and conditions apply.